Hello, everyone. This is the lecture for section 4.4, graphs of logarithmic functions. So section 4.1, we learned what an exponential function looked like, right? 4.2, how to graph them. 4.3, what the heck a logarithmic function is, right? Now we're getting into the graphing of a logarithmic function. That's exactly what we're going to do in this section, okay? Turns out, just like when we did a section 4.2, it didn't end up being anything new. You already knew what was going to happen. So this is going to be exactly the same thing, actually. Okay. So let's get straight into it. Uh, the first thing I want to do is just define a couple of things. Okay. First of all, this is the exponential. The red one is the exponential, right? And the blue one is the logarithmic. You guys see how they're sort of semi-flipped along this green line that's right here, this green line that's right there. Okay. That's because they're inverses of each other, like we had defined from before, right? Okay. So the first thing, if you recall from section 4.3, we already have the domain of a logarithmic function. We've already sort of defined this a little bit. It's going to be from 0 to infinity. Okay. We see that on the graph, right? You guys can see that our graph starts here, right? And it only goes that way for the logarithm, right? Okay. Okay. There was always going to be an asymptote. I'll fill it in right now, right? As we get closer to our value x equal 0. So there's going to be an asymptote. I'm going to draw it with my space pen right down this right here. Maybe I shouldn't make it, maybe I should space it out a little more, right? There, there. That is always going to be the asymptote for the logarithmic function, okay? Awesome. And then one last thing. The reason why our domain is this, right? The reason why our domain is this, it's because the inside of the logarithm has to be positive. Sorry. Yeah, positive. So that answers our next, right? Our next blank there. The logarithm, the thing inside of the logarithm has to be positive. Remember how, so this was the new addition to the things that we can't do in math, right? The first one, can't divide by 0. The second one was can't take the even root of a negative number. We sort of excuse that away. If we do that, we say, all right, we're talking about complex numbers. This is now the third one that we cannot do. We cannot take the logarithm of a negative number, okay? And that in and of itself is how we find domains and ranges, okay? So let me go ahead and do this first one. Domain and the vertical asymptote. So it turns out that if we do these, right, we get both for free, okay? So what we have to do here, right, just like we did before, are we doing any of the three things? Are we dividing by 0? Are we doing the square root of a negative? And are we taking now, this is the third one, are we taking the logarithm of a negative number, right? Okay, so to find these out, right, it's pretty simple actually. See that thing inside the log? We just need to make sure that that thing is bigger than 0. So x plus 3 has to be bigger than 0, right? And when you have inequalities like this, right, you solve them out just like you did when they were equal signs, right? So then minus 3, so x has to be bigger than 3, okay? This automatically gives us our domain. -3 to infinity. That's what this thing gives us. Okay. Now, there was one more thing, the vertical asymptote, right? That is also going to be x equal -3. Boom, all done. You guys see how simple that was? Okay, next example. Same idea, right? So I need the 5 minus 2x. I need that to be bigger than 0. So basically my inside thing right here, I need to make it bigger than 0. I solve this out. So -5 minus 5 minus 2x is that thing minus 5. Okay, now this might be something that you guys might remember from high school. When you divide, so right here, the next step would be, right, divide by -2, divide by -2, okay? That cancels these two out. Whenever you divide by a negative, it flips the sign toward the other direction. So now I'm going to have this. X is less than 5/2. Okay, this gets us our domain. Domain. -infinity to 5/2. And our vertical asymptote is also going to be, x equal 5/2. We are done. Okay, so then that means if you graph both of these, if you graph this one and this one, right, we are going to have vertical asymptotes here and here, and the x values won't go before that or that. All done. Okay. What comes up next? Quick checks. Okay. I'm going to have you guys try these out. Now let's get into the actual graphing portion. Okay. Thankfully, I included this graph in your packet of graphs already, so you don't have to go search for it. Okay. Here it is. Okay. Let me fill in the last couple of points on the way down. So hopefully you guys see, right? B cubed is going to be 3. B squared is going to be 2. B to the first, hopefully you guys see the pattern. B to the first is 1. 1 is going to be 0. Hopefully you guys remember where this one came from, right? It's going to be, this is going to be B to the 0, comma 0, and then B to the 0 is always 1, right? From section 4.1. The pattern continues after that, okay? So right here, you're going to have, I'm going to go ahead and do -1, -2, -3 on the y's, right? But then this is going to be B to the -1, B to the -2, B to the -3, okay? And these can also be rewritten, right? 1 over B, comma -1. 1 over B squared, comma -2. 1 over B cubed, comma -3. So all of these are equivalent statements of the same point. Okay? All right. Now let's get into answering some of the other questions that are on the left-hand side of the screen here. Okay, so suppose we had a log base b of x, the function itself, right? It will have the following characteristics. Okay, is it 1-to-1? Heck yeah, it is. If you guys remember, right, 1-to-1 is a horizontal line test, right? Okay, vertical asymptote, always going to be x equals 0. It's going to be right here. It's going to be this right there, okay? Domain, always going to be 0 to infinity. My range is going to be -infinity to infinity. That's all the y values, right? There's going to be an x-intercept in this case. It's going to be 1, 0, okay? The key points, those are on the graph. Just sort of, at least for the first 1-2 times that you graph something with it, right? You know, be a stickler about it. Put down the points, yeah? After that, we can let Desmos do everything for us, okay? Y-intercept, none. In this case, there are no y-intercepts. It does not cross the y-axis. And then lastly, increasing, it's always increasing. Negative infinity to infinity. Okay? So, I'm going to graph one just for practice. Yeah? I'm going to graph this one, log base 3. We can have that 3 be whatever. It can be log base 3, log base 5, log base 27, log base 11, right? In this case, I'm just going to do log base 3, okay? Just as an example to how to graph it, okay? Like I said, after this, let Desmos graph it to your heart's content, okay? Okay, so here we go. So we know that the first point is going to be 0, or sorry, 1, 0, that point right there, okay? Let me scroll back up. The next point is going to be b to the first, comma 1, right? In our case, b is 3, so it's going to be 3, comma 1. 2, 3, comma 1. Our next point after that, b squared, comma 2. That's going to be, so in this case, in our case, our b is 3, correct? So it's going to be 3 squared, 9, comma 2. 9, comma 2. The next point is going to be b cubed, comma 3. 3 cubed is going to be 27. Hopefully you guys see why the graph is so huge. Okay? And then the rest, from here on out, it'll go like this. It'll be down here, closer down, so on and so forth. Let me actually write down the points. So this one's going to be 1, comma 0, 3, comma 1, 9, comma 2, 27, comma 3. These are the more, I guess, troublesome ones, right? This is going to be 1/3, comma -1, 1/9, comma -2, 1, I made the one way too big, 1/27, comma -3. Okay, and now we do the connect the dots, just like we did in kindergarten. There's a reason why I like Desmos so much. It can graph these already. There's our final graph for log base 3. There's the final graph for log base 3. Okay, so you can see, right, my domain for this, let me do it down here. My domain for this, right, is still going to be domain 0 to infinite, right? My range is going to be -infinity to infinity, and then the vertical asymptote, notice it's still the same. It's going to be x equals 0. We're done. Okay? Like I said, graph one of them at least. So graph log base 4, log base 5, something. Okay? Just so you can get sort of a feel for the points themselves. So basically these. I want everybody to get a feel for those right there. Okay? Do it once. After that, like I said, let Desmos figure it out. Okay? Okay. Now we're getting into the stuff that we already know. Okay? So in this case, I need to graph that. Okay? We graphed a nice little general version of it just now before, right? So it's got to go through here. It's got to go to 1, 2, 3, 1, 9, 2. Okay, and then it goes a third, a 9th, a 27th. Okay, so what I'm doing here is I'm graphing the, I like to call it the vanilla version. This is just log base 3 of x. So this right here is just log base 3 of x. Okay, hopefully you guys see that there is an asymptote along that right there, right? So let's go through this. We have two things here. There's a +5 and the -1. The +5 is inside with the x, and since it's positive, right, that should tell you it is a horizontal shift, so it's a left-right shift, and it's going toward the negatives by 5. Got it? And then the -1 tells you to move it all down 1. Okay? So my final graph is going to be this. And I'm going to grab these points exactly. So I'm going to re-highlight them in purple so you guys know what I'm talking about. Right? Those points, I'm going to move them to the left 5, down 1. Okay? So this point, left 5, 1, 2, 3, 4, 5, down 1. 1, 2, 3, 4, 5, down 1. 1, 2, 3, 4, 5, down 1. Okay? And then I'm going to, remember how I said it, do a couple just by hand, just to get yourselves used to it. Okay? Okay, last three things that we need to do. State domain, range, asymptote, and x-intercept. Okay, domain. I'm going to go ahead and do it up here. Domain. As you can see, my asymptote all got moved over to -5. So my domain is going to be -5 to infinity. My range. This is still -infinity to infinity. It goes from all the way down below. I forgot to put the arrows on it, but right there, right, all the way up. This still keeps climbing, so it doesn't stop growing, right? Okay, asymptote. There's a vertical one, right? And if you look at the graph, we can see that it got moved, right, to x equal -5, and then the x-intercept, thankfully, it got sort of moved on its own, right? So that's going to be, what do we got? -2, 0. We are all done. We are all done. Okay? One last example. One last example here. Okay? I am going to graph this one, log base 3, and then I'm going to grab graph the 3 reflections. Or sorry, the 2 reflections, right? So our base function, we know that is going to be 1 right here. 2, 3, 1. That. Like I said, it's nothing different from what we learned before. Nothing different from what we learned before. Okay? All right. Here we go. If you guys remember, right, that negative out front tells me that it's going to do a vertical flip. Okay? So instead of going up, it's now going to go down, right? I'm going to switch all of the y values to the negative values. Okay, so we have this now. This point stays right there, but this point moves here. This point moves here. And then it does the exact same thing, but now it goes upwards like this. So this one, whoosh, there we go, close enough. This one is negative log base 3 of x. I should put in blue this one. So this is going to be log base 3 of x. So the blue one is vanilla, right? The purple one is the vertical reflection. The one that's left is the horizontal reflection, okay? And just like you think would happen, right? You flip it along the x-axis. So it's going to be negative x values this time, right? So then this point goes here. This point goes here. This point goes way the heck over here. And then it tapers off like it did before. Here we are. Got it? Log base 3 of negative x. So notice, remember what happened with exponentials, right? When the negative was inside, right? That was the trigger for the horizontal reflection. Got it? Okay. All right. After this, what do we got? Quick checks. I'm gonna try them out. Okay. Be nitpicky. You can try these out at home first before you come to class, but I'm pretty sure everybody's probably sick and tired of it, right? Do as best you can. Be as nitpicky as possible when you graph these, okay? We'll try these again in class, all right? Besides that, it is lecture questions. If there's any questions about anything that I covered in the video, please ask me during class, during our quick checks, or come to my office hours. Sound good? Besides that, happy studying.